Hello class, today we are going to study a very important gas law known as Boyle's law. So we'll see the statement first, then we'll derive the mathematical expression for Boyle's law, and after the derivations we need to do the numerical based on the Boyle's law. So first we'll look on Boyle's law. So this Boyle's law is based on the relationship between the volume and pressure. So this is the general thinking that if we increase the pressure, then the volume of the gas decreases, and if we decrease the pressure, volume of the gas increases. So it is based on this concept. Okay, now let us see what this statement tells us. So according to the Boyle's law, it says that volume of a given mass of a dry gas is inversely proportional to its pressure at constant temperature. So we'll try to understand with the expression. So according to this statement, it means that if you keep a fixed mass of a gas at constant temperature, then the volume of that is inversely proportional to its pressure. That means if you increase one, other will decrease. If you decrease other will increase. So mathematical expression for Boyle's law is, suppose a gas occupies volume V1 when its pressure is P1, then according to this Boyle's law we can write V1 is inversely proportional to pressure. So one inversely proportional is given by 1 by P1. So over here, when you remove this proportional sign, we'll put constant, let that constant be K. Okay, over here is small k. Now when you just cross multiply, P1 will multiply V1, so it becomes P1 into V1, and this V1 does not have in number, so it is 1 into K, so that will be K. So we can write P1 into V1 is equal to K, that is constant. Similarly, if you consider for the second gas, if V2 is the volume occupied, we can see the final volume, and when the pressure is P2 at the same temperature, final pressure, then we can also write for that expression in similar way, V2 inversely proportional to 1 by P2, or V2 equals to K, that is constant, by P2. So when you just cross multiply, once again it becomes P2 into V2 equals to K, that is constant. Now over here, if you see, both these values are constant, so we can just make equal to this terms, that is P1 V1 is equal to P2 V2 equals to constant at constant temperature. This is called a Boyle's law equation. Now from this equation we can also define Boyle's law in another form. So Boyle's law may also be stated as, if you see, it is the product of pressure and volume, or the product of volume and pressure of a given mass of a dry gas at constant temperature. Over here the temperature should be kept constant, is constant. So according from this Boyle's law equation, we can write the product of volume and pressure of a given mass of dry gas at a constant temperature is constant.